Hello, and thank you for joining me. You're here with data science teacher Brandon, and we're going to learn about the boxen plot. Now, this is one of my favorite plots. Kind of combines a lot of different things, and you have a lot of flexibility on how you can control how it evolves and how it plots, and so you get what you're looking for. And it's a hybrid of a histogram and a box plot. Kind of tries to make up for the what each of those lack, and hopefully lots of times you can get something a little bit better than just one or the other. Okay. So here what we're going to do is take our standard seaborn syntax, data equals df, x equals our variable, our column that we want to select, and then we're just going to show. So the way this works is just like our standard box plot, 75th percentile, 25th percentile, the median in the middle, and so this box is the interquartile range. The way the next ones work this is the 75th, 80th, 85th, 90, 95th, 100 quartile if you weren't considering the outliers. So if we didn't think about these outliers, this would be the 100th percentile, and this shows you the evolution kind of steps of 5 percentiles and then up to your 75th percentile or 25th percentile. Okay? The next thing, just showing we can look at a different plot and really highlighting that this is still doing the outliers that a box plot is known for. So these outliers will start, this will be your interquartile range, the main block box, and then from here, 1.5 times this will be where the outlier, the definition, the classic definition of an outlier starts. This is a good thing about a box plot is it really highlights outliers. So this is a good thing to use in a boxen plot if you're concerned about outliers, the traditional definition. If you're not concerned about outliers at all, you can go to show flyers equals false and just turn off all outlier, and you get a full distribution plot without highlighting the outliers. Okay. One of the cool things about really seaborn in general is we can put a category across one of the axes, and it will automatically group by that axis. And so gender usually has a big impact on pretty much everything. And so here we can see as well in our writing scores, gender does really, the distributions really sit quite differently. We can see the main box is quite a bit lower. We can also see we have outliers on both sides of the writing score. Now what's really interesting as well is we can really highlight the outliers in one side, on the other side, we really get in a sense of the longness, the sparseness that's probably around this area. So it does have outliers, but it very slowly goes out to outliers. So we might be safe cutting or truncating those outliers for a machine learning model all the way up to here. And this is something that you can't really get from any other plot. Okay, so we can change this, and this is representative of the way the data isn't there. So that you can really see this shows there really is not a lot of data right here because it's so skinny. If we want to show where the area is, or sorry, the portion of the data covered, we can use scale equals area. And we get a nice thicker, and you can really see how much data it is where this is. So this is representing how much data is there, and you can see as the data starts to get a lot thinner, you can really start to see how much this truncates down, but you can also see the boxes here are bigger from the very beginning. So there's more data represented right in this area than there is in this total box. It's kind of spread out versus this one that's very kind of not truncated, but pushed in. It's very close. It's very narrow, the distribution rate. Okay. So we can also do things like a really easy way to control the number of boxes or how this evolves is that k underscore depth equals 3. Here we're going to have 3 boxes. So the main one, 2, 3. So this spreads out and then goes down. And you can do something like if we wanted to do 7 versus the 5 that we normally have, you can just get a little bit of different plot, a little bit more. You can see the texture of how it goes down. You can go quite and keep going like that. And you get an idea. Depends on how much of a sense and how important the outliers are to you. And you really want to see, you can really highlight here how thin the data gets over here. And so you don't even really need the small histogram plot. Might be just a very small line that you can only see 1 or 2. But here you get a real sense of the thinness, how little data there is in this area. And really for how long there's very little data. So this is really just, again, this is my favorite plot. I think we can get a lot from this. It combines a lot of the things from plot or a histogram and a regular box plot. And I think it's really truly a modern version of a combined plot of both of them. So thank you for joining me, and I will see you next time.